Okay, 10. They give me a function. They say which of the following is true. The first one asks for a limit. So I remember my flashcard. X is not approaching infinity, so I think to factor. So I rewrite f like this. So it would be x subtract a divided by x subtract a multiplied by x plus a over 1. Whenever x has a value other than a, 0 when x is a. We don't want to talk about any part of that. Cool. So everyone has to remember this. This fraction has a special value. In fact, it has only one of two values. Raise your hand if you know. What are the two values that that fraction will always have? That fraction is never equal to anything else. Hayden? 1 and undefined. How many knew it? 2 points. So when x is equal to a, this is 1. If x is equal to anything else, undefined. But in this particular function, you don't ever use x equal a on this formula, so this will always equal 1. Therefore, my formula for f looks like this. Questions? So now I can check the limit. Left and right limits. It doesn't matter whether I choose a little more or a little less than a. I need to use this formula in either case. So that means my limit, as x gets close to a, either from the left or the right, is simply going to have a y-coordinate whose value is 2 multiplied by a. And we're going to talk more about that.
Where did you get the 2? The 2a?
So are you okay to the green,
Yeah.
Ashlyn? So I'm thinking, okay, limit means I want the x-coordinate to be close to a, like a little more or a little less, which means I have to use this formula.
Yeah.
So if I were to plug in a little bit less than a, I'd have this, which is really close to 2 times a.
Okay.
If I plug in a little more than a,
Oh, okay.
you with me?
Yeah, I get it.
2 points. Anybody else? Cool. One thing to make sure you're doing, make sure you know the why of every step. Like I was helping someone this morning on this problem, and they were quite convinced that they knew how to get the right answer here and here, but to be honest, they were way off. Like the logic they were using will not work. Like they'll just, they luck out on one problem, the next 10 they miss. So make sure if you're uncertain as to the why, you talk about it. So, cool? So we know the limit exists because the value of the limit is 2 times a. Raise your hand if you know if f of a exists. Hands up, who knows? How many know that f of a? And then keep your hand raised if you know what the value of f of a is. Jane? 0. It says right here, if you plug in x equal a, the y-coordinate is precisely 0. So the value of f of a is precisely 0. How many knew it before he said it? 2 points. Okay. Questions? Anyone? Please, Maya.
I'm just confused by where in the direction it says a does not equal 0. Like, what are they implying?
Oh, up here. Gotcha.
Yeah. That threw me off.
2 points for Maya. Honestly, like, they'll put in a clue like that pretty regularly. They'll say a is positive, a is not equal to 0. Most of the time it doesn't really matter. The reason they had to do it here is because if a is equal to 0, you get kind of problems. You get more things going wrong than we'd like to have happen. You get like double answers instead of just one answer. So that's why I put that in. So. Last one. The function is not continuous at A because the limit and the value of the function don't match. To be continuous, they both have to match. This is a removable discontinuity. So.
Can you say that one more time?
So in fact, I'll do a different thing just to help you with flashcards. So I use this little memory aid to remember 3 different things. So the first thing I remember is that there are 3 types of discontinuities: vertical asymptote, jump, and removable. Okay, second thing I remember with my 3 fingers is the definition of continuity at a point, which is the function is continuous at a point if the left limit is equal to the right limit is equal to the value of the function. That's written down somewhere. Let's write it down again. So function is continuous at A, so we could say f of x is continuous at x equal A if the limit from the left is equal to the value of the function right at A and is also equal to the limit from the right. So that's the second of 2 things I remember with my 3 fingers. The third thing I remember is what causes a function to be not differentiable. So function's differentiable if it's first continuous, second no corners, third no vertical tangents. So those are the 3 things I remember with 3 different fingers. Wait, you need to do that again, just wait. One more time?
Yeah.
So 3 things to remember. First thing, function's discontinuous at a jump, removable, vertical asymptote. Second thing to remember, this definition here, which is a function is continuous at a point if the left limit, left limit, right limit, and value of the function are all the same. That's the red definition. The third thing I remember with my 3 finger here is a function is differentiable. The function is continuous and has no corners or vertical tangents. Not vertical asymptote, vertical tangent. You need me to say it again.
Can you just say the third one again?
So the third one is a function is differentiable. The function is first continuous and also has no vertical tangents or corners. And I'll get the order kind of different every time I say it, so it doesn't really matter. So, anybody else? So anyway, this function is not continuous. So these 2 are true. The third one is false.
Is it because they're approaching? Like, I guess I'm saying, because isn't it 0 at A?
So what happens here is, to be continuous at x equal A, we have to have this be true, Brennan. So f of A is what value, Brennan?
0.
Good. What's the limit from the left's value?
2A.
Per limit from the right?
2A.
Right, so because the 3 aren't equal, not continuous.
Okay, even though you don't know what A is, because what if A is 0? Like,
Oh, A can't be 0.
okay.
That goes back to Maya's question.
Okay.
If A were 0, then this would be true.
Okay.
So you'd end up with a troublesome problem, because if A's 6, this is not true. But if A's equal to 0, this is true. That's why they had to exclude that one.
So if you were to like make that on a graph, it would be that the thing with like the dots above it, because there is a value for it, but it's just not in like one line.
Perfect.
Okay.
So the graph, I don't know the curve, well, I do know exactly. The graph's going to look like this.
Okay.
Does that make sense?
Yeah, because that's what I was confused. I was like, how is it not continuous even though there is a 0, but it's because it's not. Okay.
You're good. 2 point. Please.
We go over 11.
Uh-huh. Anybody else here? Austin?